Hello students, I'm Mr. Hoong-Cheng and I would like to teach you the practical 9, that is the creating and modifying database table. Okay, let's take a look of the learning objective for today. Okay, so you must be acquainted with the data definition language and learn how to define create Oracle database table, okay, using the create table statement, and review the table structure that you need to use the describe table, okay, to view the table structure, and list the data type that available for the column. Okay, we need to have certain data types on it. Okay, we have 3 major data types, that is the number, that is the character, and the date. Okay, so for this lesson, please do not run any scripts because you're going to create the tables, okay, that might have the same name. But if you have run the script earlier, okay, using your own computer, but now mind you can still drop the table using the cascade constraint that will remind you along the practical lessons. Okay, so let's take a look of the introduction of SQL. Okay, most of the students like to pronounce it as SQL. Okay, please don't do that, okay, because SQL is the previous version of SQL. Okay, SQL is SQL, SQL is SQL. Okay, structured query language SQL is the standard query language for relational database. Okay, so we have a 5 category. Okay, when you select the statements, okay, to view the data, to select the data from the table, you need to use select statement that falls under the category data query language. Okay, when you want to store a data at a table, okay, known as a file, you need to have to create table. For example, an object, a table. We need to use the create table that is falls under category data definition language. Okay, you can still modify and delete of the database object, okay, which you will learn in database system, okay, next semester. So for the data manipulation language, after you create the object that is a table, you can insert the data that is using the insert statement. If you want to change the data inside the table, you can use the update statement. If you want to remove the data, okay, inside the table, you use the delete statement. Okay, that's under data manipulation language. Okay, what about the data control language? When you create an object, okay, you do not want all the people to modify, to grant access to able to view, okay, the data. Okay, some of the data are sensitive and some data you do not wish other people to modify it, okay, without permissions. That's why you grant privileges, okay, to the users, okay, what type of actions they can do, okay, to the object itself, okay, whether they own it or don't own it, okay. For the last one is the transaction control language. Okay, so after you have done the data manipulation language, such as the insert the data, you update the data, delete data, don't straight away close the database. Okay, you need to use transaction control language to save, okay, the data, the changes that you have done, okay, using the data manipulation language, such as the commit statement, okay, to confirm the changes. If you do not want, okay, you want to undo the changes before you do the commit, okay, you still can undo the data manipulation language statements, okay, issue statement to the database, undo the changes before you issue the commit. Rollback, there is rollback, undo the changes. So if you without use a save point, okay, if you've done halfway, okay, data manipulation language, and you do until the end, you notice that the first half that you want and the second half you do not want. When you did the save point at the middle, you can roll back to the middle, not up until the beginning, undo the change at the beginning. So that's the use of the save point. So this will be learned in the database system next semester. So when you want to create a database table, you have to know, need 3 things, okay. You need to have to specify the name. You need to have at least 1 attribute, okay, with an attribute name, and also the data type, and as well as the sizes. Okay, for the naming, you can have from 1 character to 30 character long. Okay, for I ask you to have a shorter attribute and table names because it's easier for you to issue the SQL statements. Okay, if you have a long table name and long attribute names, it's very tedious to issue the SQL statement, okay, to select the tables and the attribute. Okay, the table you can contain the symbols, that is the underscore, $sign, and the hashtags. Okay, so we must begin with the characters. You have to remember that cannot be a symbol and cannot be a number. Must be a character or letter, and must not be an Oracle reserved word. So what do you know about Oracle reserved word? When you issue the statement such as the select, insert, update, where, from, having, all these are Oracle reserved words. You cannot use it in the table and as well as the attribute names. You have to bear in mind that when you have created the database name and attribute name, you cannot reuse, okay, to rename again for another table or another attribute. So you have to take care of it, okay? So let's create the table. It's the three simple thing you want to create the table. That is a create table, table name, column, this is the field name, and the data byte as well as the sizes. Okay, let's log into the database. So before you log into the database, what you must do, you must ensure the services are run. Okay, the services are on. So if you don't on the services, you cannot connect to the database. So you scroll to the Oracle. So the first thing you must on is the listener. Okay, the second one is the Oracle Service Database Service itself, the UTAR database service. Okay, for the VSS Writer, and the DB console is optional for you to open, to run it. For the VSS Writer is some sort of the backup and recovery. And for the DB console is for the enterprise manager, for the system administrator. Okay, for right now, just run the listener and the Oracle Service UTAR. So let's connect to the Oracle database. So I'm using the command prompt that is different from the SQL Plus. You still can use the SQL Plus, it's more or less the same, okay? But if you use the command prompt, make sure it is run as the administrator. Okay, so before that, you need to issue SQL Plus if you're using command prompt, and always use the user system, and then with the database UTAR with the password Oracle. Okay, so at the ribbon here, I want you to change some properties. Okay, properties here. Okay, properties, make sure you change to quick mode to insert mode. Okay, quick mode, insert mode. And then for the fonts, okay, you can use the Lucida console, change it to bigger fonts. Don't use the raster font, because raster font sometimes will give you the symbols that is incompatible. Okay, incompatible, that might give you incorrect, give you error when you run the SQL statement. Or you can use either Consolas or Lucida consoles, okay, for the fonts. Don't use raster font. Okay, so for the screen buffer size, the width, I want you to change to 800. Why? Because I will tell you later. Because if you want to set the line size, it does not appear in one line, okay? When you set the line size, bigger line size, it will appear in one line. So set the screen buffer size width to 800, recommended, and the color background with white color and the screen text with black. You can change to color as you like. So I have a bigger fonts right now. So why I want you to set to the screen buffer size. Okay, let's check again. Here, layout screen buffer size width to 800. For example, if I have already previously run the script already, it's already stored in the database. So I select all from employees. Okay, employees. It does not appear in one line. Okay, so you want to make it in one line, you just set the line size to bigger lines to 1000. Okay, provided you have set the width buffer size at the properties, then you run the script again. So it will appear in one line. So that's the reason. Okay, right now you have done this, okay, I've already provided you another text, okay, there's a Practical 9 SQL guide you can download on the YouTube or on Webble, okay. So it's easier, extra examples as I go on through the lessons, okay, for the tutorial, for the practical lessons. Okay, for the slide number 6. So if you want to create the table, you have to bear in mind you need to have the table name after the create table statement, and then you need to have a bracket, and then you need to put the attribute name that is field, column 1, column 2. And then after you put the field name that is column, also known as attribute, and then you need to put the data type, okay, data type, what type of data you need to store, okay, and then also the sizes, okay. So let's create a simple table. For example, I want to create a table with the table name testing, and then with the attribute name field 1 and the data type number. Okay, for data type number, you can have the optional not to set the sizes, or you want to set the sizes. It's up to you. Okay, when you create, okay, you just right click and copy. If you want to type also can, no problem. Okay, after you have create the edit mode on, and also this one, the insert mode, then you just right click, copy the scripts, okay, and see the table creations, the simple table creations. Okay, there you go. The minimum, okay, for you to create the table, you must have at least one attribute, okay, with the data type. Okay, so let's go on. Okay, data type is to specify what kind of data you need to store, okay. We have the numbers, we have the characters, we have a date, we have a time, okay. So we have three majors of the data type inside the database, okay. That is the numbers, okay, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay. Or we have the characters, that is A, B, C, D up to the Z. And then we have the date, okay, for example, today's date is 22 March or 2020, and 3 o'clock, 4 o'clock, 15 minutes and 30 seconds. Okay, those are the different data types you can store inside the database. Okay, for example, we have a character and characters, and then we have the VARCHAR and VARCHAR 2, and then we have the number, we have the date, time, interval, and for the multimedia files, large binary files, that is the raw, blob can store the JPG, WAV file, as well as the songs MP3. Okay, before I go to the example at the practical, I would like to explain first one by one, okay, what are the differences between these two. Okay, for the characters, we have the VARCHAR type. Okay, we have the VARCHAR and we have the char. Okay, if you use the VARCHAR, it has the variable length of the data. It does not pad the empty spaces, fixed length size, okay, pad to the maximum fixed length size. Okay, so for the characters, it stores up to 2000, okay, compared to VARCHAR 2. VARCHAR 2 can store more than char, okay. So for the character style is the 2000, and the maximum for the VARCHAR is 4000. Okay, for the VARCHAR and character, do you still remember the ABCD? It is represented as the ASCII code, okay, the American Standard Code, okay, for this one. Okay, for the ABCD and numerical. But if you want to type in, for example, Arabic, Jawi, Tamil, or Chinese, okay, Japanese or Korean, you need to have the Unicode, okay, to have the extra symbols to be represented. You need to use VARCHAR2 or VARCHAR, okay, to represent all those characters other than English, okay. So we have the number data type. Okay, number data type, it stores from the floating point 10 power of negative 100 up to 10 power of 125, okay, with the precisions up to 38 decimal places. Okay, you can see, okay, the data, very large data, floating point. Okay, for the general syntax, okay, for the number, we have the precisions. Precision is the maximum number of the digit, and the scale is the decimal point, okay, how many decimal point you want. Okay, floating point and the numbers, okay, so I will go on detail. Actually, floating point is the same as a number, it's a subtype of number. Okay, so I've already explained up until number, and then let's go to dates. Okay, date, you can store date. Besides dates, you can store time as well. Okay, so if you define the data type as date, you can insert using the to date, this one, to issue the time as well when you insert into the date data type. Okay, but timestamp is the same like the date, but it has the more fractional second precision than the date. For example, 17, 25, 30. You can see here the fractional second 9, 26, 01, 1, 2, 3, 9, 7, 5. Okay, you can have even fractional second precisions. Okay, thousands of seconds, even more precise for the timestamp. Okay, so for the example of creation, let's go back to the this one, number 8. So let's go to the practical 9 SQL guide. Okay, we have the character and VARCHAR tool. Okay, they always say, why use char and why use VARCHAR tool? Okay, there are a difference, you know. VARCHAR tool is much more efficient than char. Okay, for example, it is fixed length for characters. For example, character 5. We have 5 spaces allocated. When you store Ali, okay, 3 spaces used, we have 2 empty spaces remain. Okay, you have Mary, okay, if you define it as char, we have 4 spaces and 1 empty spaces. And Sheng, okay, is full, use up the full without empty space remain. But if you use variable characters too, okay, VARCHAR too, if you use Ali, okay, 3 space used and 0 space remain. Okay, so this one you save spaces when you save, okay, the text inside the database compared to char. Okay, use up more spaces than the VARCHAR tool. Okay, so there are difference. Okay, for the evidence, let's go and create and see. Okay, let's create a simple table char type. For example, create table T with the field 1 with the size number 5. Okay, let's create this one. Okay, you can describe, okay, to see the table structures. Okay, to see the table structure, you can always define. But before that, if you set line size to 1000, if you want to describe, you must set back the line size into smaller line size. If not, it's very hard for you to describe the table. Okay, set it back to line size 100. So if you want to describe the table, so if you want to appear in one line, you set back the line size to 1000. Okay, so you can see the table structures. We have the field name, and then we have the data type and the sizes, and then you can see whether it is null or not null using the describe table. Okay, describe table. Okay, after you have created this table, try to insert the value. Okay, this will be learning in the next practical lesson, but I intend to introduce the insert statement for you to understand, okay, the purpose of create the table. Okay, to insert the table is very easy. Insert into the table name. Okay, this one is without column list, without specifying the column. I straight away put the value Ali. Okay, so the insert the value to column field 1 with the value Ali. Okay, when you populate the data, with the Ali. When you want to view it, you can use the DKL statement, data query language, to view the data from the database. Okay, so when you select all from tchar, you do not know the empty spaces, okay? Whether it is empty spaces reduced or we have a padding, okay? Empty spaces to the right too. You cannot guess it like this. So I have prepared one code for you. Okay, you can use this code to check to blank spaces. Okay, so we have the character 5 use up 3 spaces. You need so you have empty trailing blank spaces at the field for Ali. This one. So let's check this one with test. Select field 1 from tchar and select rec xp count field 1, the empty spaces, and then from test. And then we have 2 empty spaces, correct or not? 1, 2, 3, 4, 5. That's why if you use character, even though you have not used up, okay, all the spaces, it will still remain, okay? Field character 5, spaces 5. It does not shrunk, okay? Shrunk to become 3. So it wastes a lot of space, okay? If you use char. So you might skip this one for the end character. I tried, it works, okay? But you need to do some sort of the changes. Okay, before you try to attempt, okay, for the Chinese language here, you need to change, you need to go to the control panel. You need to go to clock and regions, and then you need to go to region, and then you need to go to administrative, and then you need to change to system local, and then you need to change to Chinese simplified, and then click OK. You need to restart your computer or log off, okay? But for this lesson, you just skip it lah, okay? If you want to try after this lesson, you set the setting I've mentioned here, and then you try to create this one and insert, and then view the Chinese character. It works, okay? I tried it already. Okay, let's skip for the nchar. Nchar is for the Chinese, Arabic, and Tamil, and for the Jawi and other symbols lah, okay? So creating a table with the varchar2 type. Okay, so you do not confuse with the varchar and varchar2, which I'll explain later. Okay, why you should use varchar2 instead of char? Because char could be used storing fixed length. Okay, it's a waste of space. Okay, it pads all the unused spaces up to the maximum you have defined. But if you use varchar2, so if you have the maximum the sizes already defined, you only use less than of the maximum, it will truncate, okay, all the empty spaces, so it will save spaces. Okay, and secondly, varchar supports more characters than char. Okay, and now the issue is why varchar2? Okay, varchar2 is the older versions, okay, of the standard, and then it will be replaced by varchar2 in the futures. That's why when you want to declare the varchar data type, always use varchar2, okay? Don't use varchar, okay? So varchar can store only 2000 bytes, and varchar2 can only 4000 bytes. And that's still the same, okay? Varchar is the same like char. If you have the fixed size, okay, they do not truncate, okay? And also ANSI is the SQL standard, okay? ANSI, varchar. But varchar2 is the Oracle standard. That's why Oracle itself, they use varchar. Because varchar always change the definitions, okay? That's why Oracle introduced the varchar2 that will not change. It is the standard, okay? And also varchar is the external type, and varchar2 is the internal data type. But there's a difference. Varchar can identify null and empty strings, but varchar2 cannot identify both. They consider both the empty string and null the same, okay? Empty string and null the same, sir. So, but you can see varchar2 has a lot of this one advantages, okay, except one number 7. Okay, there's disadvantages. So Oracle itself recommend VARCHAR 2, just use VARCHAR 2. But if you try to force yourself, okay, what happens if I want to use VARCHAR? You can go ahead and try. Okay, for example, create table T VARCHAR. I do not use VARCHAR 2. No matter how hard you try, okay, Oracle will always convert it back to VARCHAR 2. That's why when you define the table, just use VARCHAR 2, okay? Don't be stubborn, okay? No matter how hard you try, Oracle will convert back to VARCHAR 2 if you declare this VARCHAR. So that's why always, okay, always when you create the table, use VARCHAR 2. Don't use VARCHAR, okay? Now, you create the table T VARCHAR 2 and now insert the value early, okay? Okay, you insert this VARCHAR 2. Okay, insert VARCHAR 2. It's already exists, so I need to drop table because earlier I used this table before I create this tutorial video. So you can drop table to remove it, okay, if it already exists. And then I create the VARCHAR 2, okay, it's already created. And then I insert the value, okay, early. You please observe, we have 5, okay, VARCHAR 2 5. We have 5 empty spaces, but early only use 3 spaces only. What happened to the 2 spaces when you use VARCHAR 2? Okay, so you try to select and see. Can you guess? You just use only 3 empties, just use 3 spaces? Of course no, you need to have the code, okay, the evidence, okay, evidence you with test. Okay, we have 1, 2, 3. Okay, can you guess? You cannot guess, isn't it? Okay, the empty spaces. So you use this one, okay, to check the blank spaces, and the result, you will surprisingly 0. Okay, early just use only 3 spaces. Although you have VARCHAR, you have defined as 5 places. Those 2 unused spaces will be truncated. So you compare the result just now, okay? Compare the result just now with the CHAR and VARCHAR 2, okay? With the same early, okay? So if you use the VARCHAR 2, it will save a lot of storage, okay? Will be much more efficient, okay? To store the value, okay? Without wasting all your storage. Okay, for the AND characters, okay, AND VARCHAR is the same as the AND CHAR, okay, except we have much more spaces, 4,000, okay, 4,000 bytes. Okay, it's for the foreign language, okay, for a foreign language such as Chinese, this one, Tamil, Arabic, and also Jawi. Okay, you can try this one after you have done this lesson and then do some setting and restart the computer. So let's skip for the AND VARCHAR. Let's go for the number data type. Okay, for the number, we have the precision and scale, okay, to set the sizes. Okay, what are the precisions? Okay, precisions are the maximum of digit you store it inside the table. And what are the scale? Scale is the number of digit after the decimal points. Okay, for example, we have a 7, 4, 5, 6, 1, 2, 3, 8, 9. So you just count how many digits maximum. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 digits. So you must have 9 precisions. And then how many digits after the decimal point? 2. Okay, you must have at least 2. Okay. So you need to check. Okay, we have this one. From the slide 13, okay, and the answers given in slide 14, okay, but you're not that convinced, without running the scripts, okay, so you can try. I've already prepared the SQL statement and then run create the table and then insert with those the scale and precisions and see what are the output. Okay, let's create the table T number. Okay, with the precision and scales. Okay, so let's insert. Okay, let's insert for the value, all the value for all the fields. Okay, from field 1 to field 9. You notice that 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, field number 5, okay, here. You cannot fit in, okay, the value because it's too large already, okay? Because why? We have 9 digits, okay, 9 digits, but you put 7 here, okay, you put 7 here, of course, it will give you error. So when you issue a statement. So next one, I issue a null value. This one, I don't want to insert this one. And I add another field. Okay, I put 9, -2. Okay, 9 digits, but the scale will be -2. See what happens? Okay, now let's insert again with null. Okay, for the value for the field number 5. Okay, so I've already wrongly insert, okay, wrongly copy. Okay, one row created. Okay, now let's see the output. Okay, let's see the output. You select, okay, select all from this one, select all from T numbers. I forgot to put in, so you know how to select statement. Okay, select all from T number. Okay, so you can see, okay, this one, the field number 1, 9. Okay, so if you just put it 9 without put in the scale, okay, 2, it will remove the digit, okay, the 2 digit behind, 1, 2, okay, the scale. So after you remove the 2 digit, if you put 7, it should be also enough. It also can be inserted. Because if you put this one without any scale, you just take the round number only. Okay, the round number only has 7 digits. Okay, field number 1, field number 2, let's see. We have a scale number 1. So if you put scale number 1, if you put 8, also can fit in because we have 8 digits only. 1, 2, 3, 4, 5, 6, 7, 8. Because scale, we throw the 1 digit from behind and round it. Okay, round it. Okay, so for field number 3, what does it mean by asterisk? Asterisk, it means the maximum number of the number, that is 38, 1 to 38 if not mistaken. Okay, so we have 38 digit, of course it will fit. Okay, this one just only 7 digits only. So 9 number 2 will display exactly 9 digit and then 2 decimal places. Number 6, error. Okay, number 6, number 5, number 6 will give you error. Okay, it does not fit because we have 9 digits, but you specify 6 only. Okay, let's take a look for this one, the field number 6. Field number 6, we have a -2. -2, you disregard the decimal point. So you move 2 points, 1, 2 in front, and then you round it up. Okay, you round it up. Okay, 2 will go to floor. Okay, whole floor. So 1, 0. So after you throw the decimal points, we just need only 7. Okay, 7 digits. That's why if you put 7, it fits exactly. So if you put number, number is very big number. It's the maximum number, maximum precisions, and maximum scale. Okay, so of course it fits. Okay, so field number 7. Number 7, as I said, it fits. Okay, and number 8, flirts. Okay, number 8, flirts. Actually, flirts, it gives you the same okay, give you the same. Now a representation of this one, numbers of this one, because flood is a subtype, okay, it's a subtype of number. So if you want to put the precision for the flood, you have to be careful. The precision for the flood, they refer to the binary, but if you put the precision for the number, it will refer to the decimal. So if you do not put the precision for the flood, you just put flood and then it's the same as number, okay, because it's a subtype of number. So field number 9, so I put -2, I put 9. Of course it fits, isn't it, because 2 places before the decimal point will be rounded, and then we just only have 7 digits. Okay, we have 7 digits. So you have to understand okay, the scale and precisions for the numbers here. So the evidence will be here. So for the flood, as I said before, flood and the numbers, they are the same. Okay, why they need to have flood? Okay, so you have to bear in mind when you're programming, okay, when we talk to the machines, okay, they only understand binary form, okay, 1 or 0, 1 or 0, that is base 2. Okay, we have the standard for the binary floating point arithmetic, that is the IEEE standard 7254 1985, IEEE 754. Okay, Oracle work very closely, the flood data type closely to this standard. Okay, so what is the difference between float and number data type? First, okay, the precision number is in decimal, okay, for the number, okay, base 10, okay, but while float, okay, it is in binary, okay, the precisions, okay, the number of this one. So you need to convert, okay, convert it from binary to decimal. How many decimal place? It will be different, okay, different. So float is a subtype of number, and float support of the basic functionality provided by the number data type. That's why field number 8 and number 7 give you the same result, because float is a subtype of number, but provided you don't specify this one, okay, the precision for the float. Okay, why you use float? Okay, because it close to the machine language binary, okay. It is faster in calculations and also reduce the storage requirement. That's why where there's a difference between float and number. Okay, so let's take a look in these pictures. Okay, so let's take a look in these pictures. What is floating numbers? Okay, floating point arithmetics. Floating point arithmetic, that means the numbers very large, okay, large represent of number. Usually it is represent as the exponent, okay, exponent. For example, -123.154 times 10 power of 5. The sign is a negative, and the mantissa, okay, is the digit 1234154, and the exponent 10.5, okay. That is the floating point numbers, very large numbers. Okay, so for the precisions, okay, so if you for the precision, if you change from 5, 7, 7, 7, 10, okay, to binary precisions here, okay, so you need to convert. You can see that you have the different precisions, okay, here from the conversion here. Okay, this is just for the understand. You don't need to understand this one, just to show you that the binary precisions is different from the decimal precisions. Okay, for the binary precisions, it refer to 1010 numbers of 10 in the result of F. Okay, same goes to this concept here. Okay, for example, if I have a flood, okay, flood. Okay, 1/3. 1/3, 1 divided by 3, I will get 0.3333333333333 until there's no end. Okay, so if you use flood 1, Okay, how many decimal place? Float 4, how many decimal place? Float 7, how many decimal place? Okay, the float 1 here, it does not mean, okay, 1 decimal place. Float 4, it does not mean 4 decimal place. Float 7, it does not mean 7 decimal place. It means float 1 binary space, this one. 1 binary, this one. Space places, okay, 1 binary places. We have the 4 binary places. We have the 7 binary places. Okay, if you want to change the precisions, okay, want to change the precisions from the binary to decimal, you need to have this formula, okay, 0.30103 times this one, okay, times this one, 147, okay, this one. So, you know that we have a 1 to 5 digits of binary, okay, it will roughly equals to 38 digits in decimal precisions. Okay, just use the formula here. 126 times 0.3, we have 37.97. Just round up to ceiling, we have 38 decimal. Okay, same goes this one. Okay, we have float and the sizes. Okay, the float sizes, float 1 times 0.0310 is we look at here, okay, decimal place for this one. Okay, you round up to ceiling, it will be 1 decimal place. If you F2 is 4 times 0.3103, it will be 1.2. So you round up, it will be to the ceiling 2 decimal place. If 7 precision, float 7 precision, you times, you convert to decimal place, will be 7 times 0.31013, it will be 2.1. 2.1, you round up to ceiling, it will be 3 decimal place. Okay, that's why you don't confuse when you create the float, okay, you specify the precisions. It does not mean, okay, you have 7 digit, okay, it means you have float 7 binary places, 7 binary places, not decimal places. Okay, now insert into float demo. Okay, does it correspond to what I explained just now? Okay, you just view the result and see. Okay, select all from float demo. You see that? It's correct, isn't it? 0.30103 times 1. Okay, it will be roughly here, okay, 0.3. So you round up to become 1 decimal places. Okay, so we have a 1.20414. You round up to ceiling, will be 2 decimal places. Correct, isn't it? And then we have float, okay, the 3, okay, 7 times 30103 will be 2.102271. Just round up to ceiling will be 3 decimal place. So you do not confuse if you put float the size 7, it does not mean 7 decimal place. Float 7, it means 7 binary places. Okay, so you understand between the float and also numbers. Let's go to the date data type. Okay, date data type. Okay, for the date data type, we have date, timestamp, and interval. Okay, for the date, you can store it the time as well. Okay, let's create the attribute with the date. Okay, for example, create the table tDate. Okay, create tDate. Create table tDate. And then you insert, okay, the data. Sysdate is a pseudo column, okay, to store today's date and also the current time, okay. So I insert into tDate using the sysdate, okay, to store today's date and current time. And then you select the value and see. Okay, when you select like this, because Oracle default date format is 22 March 20. Okay, to check the Oracle default date format, you can always go to this table, NLS session parameters. Okay, you can select all from NLS sessions parameters. Okay, you can see that this one, Oracle date format is dd-mon-rr. You can change it. Okay, but if you set other to territory to other, for example Malaysia, the date format will be different. So you need to check it from the NLS session parameter, what is the default date format for the database. But usually for the Oracle default date format will be dd-mon-rr. So just now I mentioned already, when you store current date and today's date and current time. So where's the time? So you need to use to care, okay, to use the hour, minute and second, okay, format, okay, to show up this one, the time as well as the date. Okay, if you want to change the date format, just like ddthmon year, you can use this one, okay, to care. So after you have put to care, so you can see the time as well. Okay, is correct or not? 11, 0 and 18. Okay, so let's create the timestamp. Okay, timestamp is very similar to date. Okay, can store date as well as time, but you have the even fractional second. Okay, even more precise of the fractional seconds. Okay, so to increase the accuracy, so you create the table timestamp. Okay, create a table timestamp. Okay, table created, and then insert into the timestamp. Okay, I'm storing today's date and also current time. Okay, today's date and current time. So for the timestamp, you don't need to use to care. It will automatically show the time as well with the fractional seconds. Okay, very precise. Okay. Okay, let's go for the interval. Oracle is very powerful. Can store the range of months, year, and also day or second, okay, with the interval year of month. Bear in mind, interval year to month, interval day to second is not the date, is not the time, is the duration. Okay, duration of the year, the month, the day of the second duration. That's why we call it as interval year to month or interval day to second. Okay, to create the store, okay, the duration of the year and the duration of the month, you can use the interval year to month. Okay, let's create this one. Create table tytm, year to month. Okay, table created. Okay, to insert, okay, the range of the year and of the month, you have to understand all the syntax. Okay. When you issue the insert statement, you have to use this one, the syntax 1 to 6. Okay, it's up to you. Okay, for example, inter 1, 1, 2, 3-3. Here we have 3 places and then 2 months. Okay, it means 120 years, 3 months. Okay, to store inside the this one, the interval year to month. Okay, let's insert, for example, 10-2 year to month. It means 10 years to 2 months. Okay, let's insert. So if you want to see the duration, you just select the table and you can see the output. Okay, it will be the plus. Okay, the plus. Okay, the duration, we have the duration 10 years and 2 months. Bear in mind, this is not year, this is not month, but the durations. Okay, duration of the year and duration of the month. Okay, let's take a look for the day to second. Oracle is even powerful to provide you to store how many days, how many seconds, okay, durations. So you can create this one using the interval day to second. If you want to insert, okay, number of days, duration of days and duration of second, you have to understand all this syntax, okay, from here. Okay, for example, I want to insert the number 1. We insert 11 days, 10 hours, 9 minutes, 8 seconds, and 5 thousandths. Okay, we have a second, we have 3 places, okay, 3 places of the second. Okay, 1, 2, 3. Okay, let's insert this value. Okay, 1 row created. And then you just select and see. You can see the duration of this one, of the day, the hour, month, minute, and the seconds, fractional seconds. Bear in mind, this is duration only, okay, not the year, the day, and the second, okay, it's the durations. Okay, now let's move on to the last data type, okay, the last one, that is the binary value. Okay, when you have the multimedia file, okay, you have the multimedia files like very large file, JPG, WAV, MP3, you can convert it into the binary form and put it inside the database table. But it is less recommended because most of the database file, the multimedia files more than 4 gig, okay? Because if you use the crop and block, it's mostly you can support up to 4 gig only, okay, 4 gig if not mistaken. Over than that you cannot store unless you use another one, store the binary file outside the database table. You use B file format. Okay, let's take a look for the raw format. Okay, raw format is the storing variable length of binary data. Okay, the sizes is the 2000 byte. Okay, let's create this table. Okay, create table T raw. Okay, field 1 raw, maximum size. I specify until maximum size. So if you use the raw file, okay, I already created earlier. Drop it. Okay, I create this file, table created, and you try to insert, okay, using this one, okay, the numbers, characters. It will give you error. Okay, when you want to insert raw value, always remember you only can insert using hexadecimal number only, base 16 for raw number. Or else you use the utility raw cast to raw, okay, to change the numbers, the characters to become hexadecimal value, okay. So if you want to see from the database, everything is in hexadecimal value, okay. You cannot know. Okay, it's used good for the password, okay, or to encrypt, okay, your file, okay, to change it to hexadecimal. Okay, do not let other people easily see what are the information inside the database. Okay, to convert the hexa back to the alphabet numbers, okay, you need to use cast to VARCHAR 2. Okay, select and you want to convert back to ASCII representation for the numbers. Okay, so you can see back actually is this symbol, okay, and actually is the raw value, okay, for this hexadecimal number. Okay, for the clock usage, okay, clock usually is to store a very large text. Okay, it's recommended to use the large text. But if you want to store, okay, this one, the clock, is very troublesome. You have to use PLSQL, okay, procedural language structured query language. Okay, we must have the programming language, that is if, else, and looping, all this lah, okay, when you learn in database system, okay, we call it PL, SQL, procedural language and structured query language. Okay, it have the loops, ping, and then we have the if, else, all this lah, okay, combined with the SQL statement. So let's create this one with the clock table. Okay, table with the clock, with the ID and the day clock, data clock. You need to use, I already create the table, I need to drop it. Okay. So if you create this table, you need to use PL SQL code to append the sample text, okay, to the database. Okay, before that, I already provide you the sample text, okay. So you just move the text to the C drive, okay, to C drive. Okay, move it to C drive first, the sample text. Okay, this is sample text. Okay, so to load it, you need to use the pure SQL code. Okay, before that, you need to set the directory first, create or replace directory. Okay, for this level database application, you just copy and paste the code and observe the result. Okay, when you go to database system, when you learn the PSQL, I'm sure you understand what is inside. Okay, for this one is the parameters. You need to refer to the documentations, Oracle documentations, then you'll know, okay, how to manipulate the text further. Okay, for now on, you just copy declare up until the end and with the backslash, okay, to copy to insert the text file, okay, c.txt into the table, okay, select into the table T clock, okay, T clock, that is clock data. Okay, procedural completed. Okay, to see the text, okay, you can use dbms log substring, okay, to see the data. So if you just select from the table, select all from this one, select all from T clock, you cannot see this one information because we have just limited spaces. That's why you want to see all the information from the text file, you need to use this function. Select dbms, but before that I need to set the line size and the page size is smaller so you can see lah, okay. Okay, set the page size to smaller page size, and so this is the text file. So you compare the text file, I paste it, is it the same? Information, communication, technology, ICT, software until budget breakdown. So that's the tricks and for you to insert using the clock files. Okay, what about the block? The block also same, okay? You convert the pictures into the binary form, we store it inside the database table. But this is less recommended because some pictures now we have the high definition pictures that is more than the specified sizes, okay? So that's why another data type, you need to store it, the binary file outside the database table, that is the B file. But never mind, you just have a look, okay, how it used the block, okay, to insert the pictures. Okay, still the same, create the table T block. Okay, T block, this one. You create the table. Okay, table created. And then you need to have the PLSQL as well. okay, to insert all the blob and clock, you cannot use the normal query, okay? You need to have the programming language, okay? Programming language, the structured query language, okay? To insert the pictures and also the text file. Okay, let's copy the sample GIF, okay? I've given you. You just extract and then you paste it to C drive, okay? Paste it, okay? Okay. So let's create a directory first. Okay, create the directory. Okay, this one. And then you insert the file. Okay, from declare up until end here, you copy. Okay, the file name sample GIF, they will insert into T block. Okay, T block. Into this one. Okay, into this table and then block data. Okay, and then okay, it's already created inside the database. So if you try to see, okay, using the normal select query statement, you're not able to see it. Okay, you won't able to see it. Log. Okay, all in the binary forms. Okay. So you need to convert back into the pictures since, okay, this command prompt, the SQL plus, you don't have the ability to view the pictures, okay? So what you can do is you export as the external pictures and then use the external program to view the data, okay? Export back, okay, the data from the table to the external places. Okay, now create a replace directory, okay, as the temp. Okay, before that, you go to C drive, you right click, you new a folder and then you create and rename it as temp. Okay, temp. You create the folder first and then you create the directory inside here. So the directory created. So what you can do is you output, okay, you export back, okay, from the table to another places. Since there's a command prompt and also SQL plus does not support viewing of pictures, just only text, okay. So you export back to temp here. Okay, before that you see the picture, you input it into the database. Okay, it's like this. Is it the same? Okay, temp. The output, is it the same? Yes, it is the same. Okay, so that's why this is the technique for you to put it inside and export it back. Okay, export the pictures back. Okay, so let's go to the slide 16. Okay, that is the constraint. Okay, constraint. Another part of the creation. Okay, table creation. Okay, constraint is to restrict the data value you can enter into the field of the database. So after you have the data type to have filter up, okay, what type of category of data in each of the column, you can further, okay, restrict the data with the integrity constraint and also value field domain constraint. Okay, for the integrity constraint, we have the entity integrity is for the primary key and then the referential integrity is for the foreign key. Okay, to define the primary key and foreign key when you want to join the two tables together. Okay, so for the domain integrities, okay, is the limits the value can be placed in a specific field irrespective of the value exists in other table record. Okay, we have unique, we have the check, and then we have the not now, and then for the value field domain constraint. Okay, let's take a look for this one. Okay, constraint naming convention. So when you put the constraint name, okay, when you put the constraint, you must put the constraint name. Okay, if you don't put the constraint, okay, what will happen? Oracle will append, give you a new name, we give you harder to track the constraint. So let's take a look for the example to create without constraint name. Okay, slide 60, this one. Okay, creating a constraint without constraint name. For example, I create a primary key without constraint name. So what will happen? Okay, you create like this without constraint name, and then you use the user constraint. User constraint is the data dictionary, okay, for you to check the constraints that you have created, okay, created inside the table. Okay, so you have to be careful. The constraint name, okay, the table name at the where condition always in uppercase. Okay, Oracle database always store the table name, attribute name in uppercase. That's why at the data dictionary, you search the attribute name, table name, everything in uppercase. Okay, after you come out, you notice that constraint name will be sysco09517. Okay, it's very hard for you to keep track. Okay, that's why you need to have your own naming convention, easier for you to keep track. Okay, although it gives you the constraint type inside the P refer to primary key. Okay, Oracle 9i constraint type identifier. P refer to PK, R refer to FK, C refer to CC, N equal to NN, U to UK. Abbreviation, you need to type in yourself. This one is Oracle defined in the user constraint. Okay, so you need to follow the standard. Okay, easier for you to keep track, to put PK, FK, CC, NN, and UK. Okay, so to have the good proper naming of the constraint, you need to put a constraint. After constraint, you need to put the constraint name. Okay, the rule to put the constraint name is you put the table name first, okay, and then put the attribute later, and then put underscore to denote this attribute what is for. Okay, for example, constraint, I put T underscore PK1 from this table name, from this field, okay, underscore field 1 underscore, it is primary key. So when I create, okay, with the constraint name, it is easier for you to keep track and manage the database, okay. So instead just the Oracle default name, okay, you use back the user constraint and see, okay, select user constraint and then table name T PK1. You can see that the constraint name compared to Oracle default one, from the look of the name, I know it is from T underscore PK1 from this table, this attribute field number 1, and then it is a primary key. That's why always make good practice, always name your constraint even though not now. Okay, I believe most of you when you create table, create not now, constraint you also omit. No, put the name as well. Okay, so if you select constraint, so easier for you to keep track. Okay, to keep track from which table, from which attribute, and what it is for. PK, primary key, FK, foreign key, CC, check condition, not now, and N, UK, unique. Okay. Okay, let's go for the slide number 8. Define the primary key. So for the primary key, can be defined at the column level and the table level. Okay, before that, I will explain column level or table level. I want to ask you, okay, when you define primary key, do you still need to define unique and not null? No? Okay, the answer is big no. Okay, primary key, it is stated, must be unique and also not null value, okay, for the primary key. That's why if you define that attribute as primary key, you no need to define not null and unique, okay, for that column again. Okay, no need, okay, because primary key is already unique and not null. Okay, let's create the primary key constraint at column level. What do you mean by column level? Okay, after this one name the attribute and the data type, I straight away put the constraint. So it means column level. Table level, I define all the attribute data type, define all the attribute data type until the end. Then I only define this one, the constraint, that is table level. So you observe this one, okay, number 1 and number 2, okay. So what are the difference between column level and table level? Okay, column level, you straight away define, okay, the constraint after the column. Okay, you don't put it until the end of the column. Okay, for the primary key can be defined at the column level and at the table level. Okay, so this is at the table level. So after the end, until this one, I declare all the attributes and the data type, and then I put the constraint, call it table level. Okay, for the foreign key. Okay, for the foreign key, it can be also at the column level or at the table level as well. Okay, for the column level compared to the table level, column level, you straight away from here, the data type, you put constraint and then foreign key reference to which table. Okay, worker you have already created, isn't it? Just now to create the primary key, and then this is the attribute for the table, parent table, worker. Okay, this is the primary key, and then this is the foreign key. Okay, so this is at the column level, but at the table level, I declare everything first. Okay, I define the data type. I push the constraint at the end of the table. Then I only define, okay, the primary key and foreign key. It means table level. So for the constraint for the foreign key at the table level is a bit different. So at the constraint, employee, this one, foreign key. So for the naming for this one, for the foreign key, it's the same. Okay, employee, student. Okay, from the employee, the primary key, from the primary table, employee, EMP. From student table, STUD, and EID from this one attribute and foreign key. Okay, this is the constraint name. This is how you name the constraint. And then foreign key, and then EID, it means here, okay, the foreign table, the attribute. And reference, EMP, okay, the primary table, okay, and also the primary key attribute, okay, EID, this one. Okay, that's the meaning. Okay, that's the meaning for this one. Okay, so you create the foreign key at the column level, at the table level, you push until the end. Okay, push until the end. So table created. Okay, for the composite key. Okay, composite key, we have two attributes to combine to become primary key. Okay. Composite key, okay, we have two primary keys, okay, two primary keys for the table. Usually it happens in the composite key in the composite table, such as the ordering, registrations, payment, all those tables you cannot see, okay, abstract, okay. Usually it is a composite key. For example, I need to have the customer ID, I know what they buy, then I only know the quantity, the prices, okay, the total prices they bought, okay, they order, okay. So this is the composite. I need to have two attributes to become the two primary keys, okay, to become the composite key, okay. So if you create at the column level, okay, column level, you try to create the table like this at the column level. Can you create the composite key at the column level? It's a big no. So that's why you have to always remember, when you want to create the composite key always at the table level. It does not support column level. Okay, still the same. How do you name the constraint? Ordering, okay, ordering here is the composite, this one, composite table. Customer ID, okay, customer ID refer to this one, customer ID, and item ID, and then underscore PK. Okay, these two combined become primary key, and then refer to customer ID and item ID. So always remember, when you create this one, okay, for the composite key, composite key, it has to be at the table level. It does not support at the column level. Okay, how about check conditions? Okay, check condition can be column level or table level. Okay, check condition is to allow the certain values, okay, the condition you have set, okay, for the numbers, for the strings, okay, this one, okay, for this one, at the check value there, okay. For example, I create a check constraint at the column level, okay, and also primary key at the column level. That means I straight away, okay, to define the constraint after the attribute, okay. So for the p gender, okay, character constraint, I straight away put the constraint. I want to check, okay, the gender. Either you can enter male or female only, M or F, okay, represent by these two characters. Okay, so if you want to create the check constraint at the table level, also can. Now the primary key and the check constraint at the table level. After you define, okay, all the attribute and also data type, you push the constraint at the end of the table, okay. So constraint still the same, okay, this is a table name, PID is the attribute primary key, and this one participant still the same, P marks is the attribute name, underscore CC, okay, is the check constraint. Then check, I want to check the marks between 40 and 100, then only can be inserted into the this one, inserted into this table. Okay, can So for the not now value, you must have at least one value, okay, you cannot leave it blank, okay, cannot put now value. So now value only can define at the column level. For example, create a now constraint. For example, DID constraint, this one primary key, the name, you cannot leave it empty, okay. Dancer table, and then D name is the attribute, then underscore and N, not now, okay. The name cannot be not now. So I already created this table. So you drop table, dancer. Okay, I create again. So the name must have a value. You cannot leave it blank, now value. So I try to create the now value at the this one at the push it at the table level. See what will happen. It's a big no. You cannot create it like this. You can no way you can create this one. Okay, not now at the table level. Okay, for the unique constraint. So everything must be different. Everything must be different. But there's a now value, can be now value, but everything must be different. You cannot be the same. Okay, cannot be the same from one and another. Okay, for example, creating unique constraint, not now and PK at the column level. For example, the security key, okay, is unique, okay, for the citizen. But for example, your IC also unique. But when you create a table, okay, usually we don't use your IC as the primary key, okay, we use the ID as the primary key. But since it is unique, okay, different from another, but it's not primary key, so you put it under unique category lah. Okay, different from another. Okay, different from another. So this one is to create the unique constraint, not now and PK at column level. So after the column, I straight away put constraint. For example, this one, constraint security key, constraint citizen is the table name, and SC security is the attribute, underscore UK unique. So this one will be unique, okay, this one will be not now, this one will be primary key. So I try to create the not now at the column level, okay, column level, and also unique and primary key at the table level. Yes, if it is allowed at the table level, at the column level, you can mix it up, okay, but I always remind you, if you can put everything at the table level, just use this method, because if you use column level, it is quite messy, it's very hard to keep track, okay. So if you push all the constraint at the bottom of the table, it's easier for you to keep track, manage and see. But there's some exception. Not now cannot be at the table level, it has to be column level for not now. The rest, try to use table level instead of column level. Unless in the exam stated you need to use column level, then you have to follow, okay, the instructions. Okay, now create at the table level, okay, the unique for the text number, okay. Owner is the table name, old text number is the attribute, and then the UK, okay. Okay, another question I want to ask, some students ask me, at the column level, I already defined there's constraint, but what happens if I want to have another constraint at the column level as well? Yes, of course you can. I tried it, can. In the this one, the ID, although it is the primary key, I want it to be unique and not now, but I want to check the value, only can store the value between 001 until 9999, okay? So you can have the constraint check and constraint primary key at one attribute, at one column, okay, at one column. Two constraints at one column, defined at one column level, okay. So you try to create and see this one, no problem. Okay, we have this one, two constraints at a column, okay, table created, okay. Okay, let's go to the slide. Okay, I've already done the value constraint. How about the violating constraint? Okay, violating constraint, that means you does not fulfill the constraint, okay, will give you an error. So let's try to violate the constraint. For example, the primary key. The primary key, the constraint is must be unique, the value first. Second, cannot not now, okay. So I try to create this table with the primary key, and then I insert the primary key with the value number 1. So again, the definition of the primary key, you cannot insert the same value again. So what happens if I want to insert the same value again? It will violate the constraint. That's the unique constraint system TPK same field will one violated, okay. Okay, so if you name your constraint, the error also easier for you to keep track. You know, from owner from a system, this table T underscore PK same, this table field number 1 violated, okay. This attribute cannot have the same value. That's the reason you need to name your constraint, okay. Okay, let's see slide 21, default option. Okay, default options are when you want to insert the value, but you ignore, okay, the value. You ignore, you do not specify any value for the attribute. So it will look, okay, when you have the default value already declared, okay, here, then we use the default value here, state, today's state, and the PK. Okay, so you have to remember, okay, literal value, okay, like ABCD 1 2 3 valid, okay. SQL functions between the literal, for example, uppercase, lowercase, still are legal value. But another column name, okay, you want to put it as the default, okay, and some pseudo column are illegal value. Not all pseudo column are illegal, okay. I will show you some pseudo columns still can be used in the default, okay, such as the sysdate, okay. And the default date, okay, must match the column data type. Okay, for example, I want to have here number, but you have the character default here, PK, it will give you error. Okay, it has to be same data type, okay, same data type, the default number. Okay, let's take a look for the default options. Okay, default options. For example, creating option for number, date, and characters. Okay, I create this number. When I insert this number, when I ignore these two number, okay, I will put a default number 333 and default name, okay, star. And then I put the function, SQL function. I put this one, we convert it into uppercase, okay. Okay, right click, and then it's already used because I've tested it before I do this video. You just can delete it, okay, drop table, okay, and create this table created, and then try to insert into t default t value. Okay, I only specify t id and insert value 1. What about the rest? Okay, I ignore t value, lucky number, and t name in this insert statement. So what will happen is when I ignore the value, it will put in the default value. Okay, I just put in number 1. Okay, the default value will automatically put 333 and star to the column. Okay, try to see the result. Okay, we'll select from t default. Okay, you can see the default value will be append inside. Okay, uppercase star. Okay, because uppers this one, SQL function. Okay, certain pseudo columns are allowed. Okay, such as the sysdate is to insert today's date and current time, and also user, okay, to show which user, okay, you are logged in now, okay, to the database. Okay, you try to copy this one and paste, okay, to use these two system column. Okay, it's already exists. I've already tested before I do this video. You just drop table, it already exists, and then table created, and then insert into PID. Okay, I insert only ID value number 1. What about the rest? T date and T user. Okay, I will automatically put in today's date and put in the user in the system. Okay, user in the database. Okay, the current user use now, the database use the database now. Okay, default user already created. Now insert. Okay, sorry, insert already created. Okay, now let's see the result. Okay, I only insert, okay, ID only, okay, value 1. I did not insert T date and T user. So it will automatically insert the today's date for the pseudo column sysdate and user, okay, for the user who log in the system now. Okay, you are logged in as a user system. Okay, certain pseudo columns are not allowed, such as the famous when you go to database system, such as the sequence you cannot, next while, cur while, you cannot put inside. Okay, and also row num, row ID, okay, will give you error. Okay, these pseudo column are not allowed. Okay, but sysdate and user are allowed, pseudo column. Okay, you have to remember that. Okay, let's go to slide number creating constraint at column level, at table level. I already explained, but now let me refresh you. Okay, all the unique primary key, foreign, and check constraint at the column or table level, but now value at the column level only. Okay, But the constraint refer more than one column, such as the composite key. It has to be at table level. Okay, if you put the word constraint, you must put the constraint name. Okay, constraint table name first, then attribute, and then underscore, the PKFK, to get the abbreviation. This is how you name your constraint. Okay, so I always encourage you use table level. Okay, unless it is stated in exam, you have to use column level, then you have to follow the instructions. Okay, so not now cannot be used at the table level, unfortunately. Okay, the rest, if you can use at the table level, try to use at the table level. Okay, for the table level creation sequence, when you want to create the table, if you create the table for the foreign key first, what will happen? For example, I want to create the student. Okay, the student refer, okay, the key to the faculty, okay, FID. So for the faculty, it refers to the location ID, okay, for the primary key. I create the table with the foreign key first. Of course, cannot, okay? The primary key must exist first. Okay, because I've already done this one, okay, the testing one, I dropped the table first. If you run the script previously, I remind you again, drop the table. Okay, drop table first, drop table, location, cascade constraint. Okay, if you have run the script previously, okay, because if you use on your own PC, it will not refresh, okay, refresh data just like you're in the lab, okay, always remove the data as if it is new, okay, we'll revert back to the beginning. But if you use your own laptop, it already exists, never mind, you just follow this one, follow me. Drop table faculty cascade constraint. I will explain later. This one, drop table student cascade constraint. Okay, drop this table, these three tables first. Okay, constraint. Okay, drop already. Now, what happens if I want to create the foreign key first? I insist want to create foreign key first. Does not exist, okay, correct lah, does not exist. The faculty ID. That's why always create the table with the primary key first. You need to define the primary key first, then foreign key. So you create this one, the primary key, the location ID first. Location ID as the primary key. And then the faculty table will depend on the location table, okay, for the primary key, and location as the foreign key in the faculty table. And then in the meantime, faculty ID is the primary key. Okay, it will be used as the foreign key in the student table. Okay, the faculty ID will be used as the foreign key in the student table. Okay, that's why this is the sequence for you to create the table. You cannot create, okay, the table with this one foreign key first. You must define the primary key, then only you can reference, okay, back to the this one, the primary key. Okay, so you understand the table creations. So let's go to 25, 26, 27 is the same. Okay, I put in a text file. Okay, to check the table's constraint, okay, there's a data dictionary views, okay, user constraints for you to check the constraint name and constraint type. Okay, so if you want to see what other information that you can see from the user constraint, you just describe user constraints. Okay, what are the information you can see from this dictionary? Okay, I do not want to view all. Usually we just want to know the constraint name and constraint type. Okay, constraint type from the user constraint and faculty name. Okay, always remember when you use the data dictionary, the table name, the username, the attribute name, everything in uppercase. So if you don't put it in uppercase, you cannot search this one, okay, the result. So when you create the faculty, student, and location, and this one faculty, we have the primary key and foreign key. Okay, when you create the faculty ID will be the primary key, and the location will be the foreign key. Will based on the location ID primary key in the parent table. Okay, so what happens if I want to do it like this? Okay, drop table. Okay, before that, I introduce you another data dictionary. Okay, to check the table. Okay, the information of the tables, you use user tables lah. Okay, if you want to know, okay, what are the information can be provided by the user tables, you just describe user tables. Okay, so there's a lot of information I do not want. I just only want to know table name, table space name, status, and read only. Okay, for the faculty. Okay, is to check the table structures as well. Okay, this one using the the data dictionary. Okay, now let's go to this one, slide 29. Remove the table. Okay, you try to drop this one. Okay, you try to drop location. Cannot, because location ID is used as the foreign key in the faculty table. Okay, I want to force drop. Okay, force drop regardless we have the primary key and foreign key. Then you add another sentence that is cascade constraints. So you have to use this with care. Okay, so the other exercise to observe why you have to use it with care, then you will know. Okay, now drop first. Okay, regardless we have the primary key, foreign key, I force drop the locations. Okay, force drop the locations. Now at the slide 30, they ask you to check. Okay, observe. So after you have deleted the location table with the primary key location ID, faculty cannot reference anymore. Okay, reference anymore to location ID. So the foreign key will be deleted as well. Okay, for the faculty, for the location ID. You can see that no more location ID. But I try to fix it back. Okay, I want to recreate the table back. Okay, the next table asks you to create the table back. Okay, we create the table back. Will it be appear back? Okay, table created back. I want to fix it back. Okay, now you try to see again. Although I try to fix it back, okay, to create the table back, but the foreign key will be deleted forever, unless if you're in the next lesson for the database system in next semester, you can add in the foreign key back again. You need to use alter table, okay, alter table statement, okay, to add back manually this one, the foreign key. That's why you have to use with care when you simply drop with cascade constraint the primary key, foreign key. The foreign key will be deleted. So if you have many foreign key, okay, refer to other table. That's why you have problems, okay, with the integrity of the data. That's why don't simply use cascade constraint. Okay, use it unless you're very sure. Okay, you can fix it back. Okay, fix it back the constraint. That's the reason. Okay, that's the conclusion I've given you. Okay. Okay. Now until to the last slide, you've learned already create table, create attribute, create the data type, and then the constraint. Now try the error. Okay, here. Okay, what's the error? Okay, I put it inside the notepad. Let's do one by one. So if you see the code, wow, what I need to fix is very scary. Don't worry. Okay, we have the compiler, isn't it? The compiler will tell the error. Okay, let's run this one, the error code first. Okay, the error code, see what's the mistake, what's the compiler say. First is say student and row. Okay, when you create the table, okay, the table name, you cannot have the empty spaces in between. So either you remove the empty spaces, become start and row, or you can put underscore, okay, underscore to combine it together. So you put start underscore and combine it together and run this script again. See what's the mistake, the next one. Okay, missing right parenthesis. Okay, missing right parenthesis. You have the, cannot have the, you must have the composite key must be defined at the table level. Okay, it shows this one, CSEC ID constraint PK primary key CSEC ID. Okay, this error. So you know that when it is the composite key, cannot be at the column level. Okay, so what you must do is you push it back to the bottom of the table. Okay, so remember the composite key must be defined at the table level, so you push it to this one, to the table level constraint primary key SID CSEC ID. Okay, now after you're corrected, run this again. See what another mistakes. Okay, missing word, reference. Okay, so you cannot create a CSEC. This one must be composite key. This one. Okay, this one we have the reference cost section. It's actually references will be in the later lah. So I correct this one first. When you take a look at this one, okay, okay, the C and row foreign key and row CSEC ID foreign key and row CSEC foreign key, this one. Okay, the reference cost section. Okay, cost section, where is the table? No, we haven't created, isn't it? And also the primary key I haven't created. So you must create the table with the primary key first. Okay, you create the table with the primary key first. Try to solve this one. Okay, table created, and see what are the errors again. Okay, we have a missing word, reference. Reference is references, not reference. Okay, you correct, become references here. You correct references to run the script again. So after you run the references, so we have the missing right parenthesis. Okay, missing a bracket or the comma. Okay, missing parentheses, please for check and comma mistakes. Okay, put the comma here, and I put this one bracket here. Okay, parenthesis. Okay, run again, see what's the mistake. Invalid identifier. As I said before, when you want to define, okay, the now value, it has to be at column level. So for the not now, you put it back at the column. Okay, CSEC ID. Okay, CSEC ID here. CSEC ID constraint, not now. Okay, you push it back to the column level. Okay, after you push back the not now at the column level, see what are the mistake again. Okay, missing right parenthesis, either bracket or this one comma. So you're missing a bracket. Okay, a closing bracket, you're missing. Okay, run and see. Okay, table created. Okay, I want to ask you one thing. Since there's no syntax error, but you have logical error. I want to ask you, can you go to America and be at the same time at Malaysia? No, isn't it? Can you drink and also eat and smoke at the same time? No, isn't it? Okay. For example, can you get the grade A, B, C, D, F for the same subject at the same time? No, isn't it? That's why you need to change this N to become OR. Okay, because impossible for you to get all the grades same, okay, at the same time. Okay, it has to be different time. Okay, different time cannot happen at the same time. Okay, this one, so you change it to OR. Okay, N to OR. Okay, now drop the table, student enroll. Drop the table, student enroll. Okay, let's create again. Create student enroll. Okay, table created. Okay, that's the answers. Okay, but first, remember that you create the primary key first. Okay, the course section CSEC ID is the primary key. Then only you create the foreign key. But in my opinion, okay, after you have make these two as the primary key composite key, not now is not necessary. Okay, primary key itself is not now and must be unique. But if you put no error, okay lah, it's okay lah. Okay, but it's not much functions. Okay, much useful. Okay, that's the end of the lesson. I hope you can learn and refresh. Okay, for the next week, we'll teach you about the data manipulation language. Okay, that's the end of the database applications, okay, and development. Okay, you have to stay safe and wash your hand and always take care of your health. Okay, due to the COVID-19 pandemic. Okay, take care. Okay, bye bye.